Hey guys, it's Miss Kearney here. We are going to be doing our next mini lesson video. So just to remind you, and I know you guys already know my expectations, I want to see that you are taking the notes as I'm taking notes. If you have a question or something you don't understand, you can always pause the video and go back and listen to the video again. Or you can make notes of questions so that when you get to my station, you can ask me later. Also, don't forget, if you are ever struggling with your homework or you have questions with the practice, these videos are always on my Canvas page. So you can just go back and rewatch the video while you're at home or when you're in a different station if you need help with some of the problems. So with that being said, let's go ahead and label this as entry number 6. So your entry number 5 was the carousel from yesterday or from today's class, and this is entry number 6. So we're going to be talking about similar figures and indirect measurement. Now I'm sure that many of you talked about similar figures in 6th grade. So take just a moment and go ahead and read the learning goals to yourself. All right, very good. So our 2 learning goals, we want to be able to use proportions to find missing sides in similar figures. So we're going to be seeing that we've got 2 figures and looking for a missing side. And we're going to be using this thing called indirect measurement, which we'll get to later. So let's take just a moment and go over the 3 things that make something similar. In order for 2 figures to be considered similar, these 3 things need to happen. Now, many of you already remember that from 6th grade, one of the things is they need to be the same shape. So you can automatically look at 2 figures and determine if they could or couldn't be similar just by looking, are they the same shape? The next thing is the reason they are the same shape is because they have the same congruent corresponding angles. So the second thing is corresponding angles are congruent. So meaning the angles that match up between the 2 different figures, they need to be the same. And the third thing is we have there the same shape, the corresponding angles are congruent, and the third thing is corresponding sides are proportional. So we know their angles are the same, but their sides don't necessarily have to be the same. The reason why is because similar figures, many of you remember from 6th grade, if I said the word similar figure, a lot of you are probably thinking, oh, those are the shapes that are the same shape, but not necessarily the same size. So the angle is what affects the shape, and the sides aren't necessarily the same, they're just proportional. So we've been talking about things that are proportional, and some things that we talked about are proportional things have ratios that are equal. We know that things that are proportional, their cross products are equal. We know that when 2 ratios are equal, they have the same scale factor. So for example, if I were to give you these 2 figures here, we have 4 by 12 rectangle, and then let's say that I have 12 by 24 rectangle. And I know those aren't drawn to scale, so please disregard that. So we said in order for these 2 things to be similar, they need to be the same shape. So we know they're the same shape. Check. Okay, now we've got to figure out, are their angles congruent? Well, even though Ms. Kearney's drawing's not very good, it looks like they're all right angles. So we've got the second criteria. Check. Now the third thing is the sides have to be proportional. So what we're going to do is we're going to set up a proportion where we're going to say 4 corresponds to 12. So we're going to set up 4 over 12. And then we know that 12 corresponds to 24. So we're going to set this up. And my question is, are they proportional? So there are lots of ways that we can determine if they're proportional. One, we could cross multiply, or we can see if they have the same scale factor. For me, I'm automatically seeing that this one I'm multiplying by 3 to get to 12, and here I'm multiplying by 2. So they don't have the same scale factor, so therefore they are not proportional, therefore they are not similar. So, are they similar? Not, and we just explained why. So, just to recap, 3 things. They need to be the same shape. Their angles need to be equal, and their sides need to be proportional. So, let's look at a practice problem. This next practice problem here is telling you that we have 2 rectangles, ABCD and PQRS, that are similar. That means that we know they're similar, we've just got to find the missing sides. So if we know they're similar, we know they're the same shape, we know their angles are the same, and we know their sides are proportional. So since their sides are proportional, I can set up a proportion to solve for that missing side, which is kind of what we've been doing the past few days. So for me, I'm trying to find that x. So in order to keep them straight, I've got to make sure that I line them up correctly. So what I usually do is I say, let's let this figure be A, and this figure be B. So what I'm going to do is I'm going to set up a proportion and figure out what x is. So I'm going to choose one of my sides from figure A. Let's choose the A. And what does that correspond with in B? That's right, it corresponds with the 6. Okay? And then we're going to come back over to A, and we're going to say, now let's look at that long side, x. And what does it correspond with in B? It corresponds with 12. So now I should have A to B, A to B. Okay, so I'm just showing you that I pulled from both figures. So now we're going to solve for x. So we can do the simple cross multiplication. 8 times 12 is 96. 6 times x is 6x. And since we know they're proportional, we know their cross products must be equal. So we're going to say 96 equals 6x and solve for x. So we're going to divide by 6. Divide by 6. So x equals 16. Okay? I'm going to very quickly do one more with you. And then we're going to go to an indirect measurement. So Miss Trina's got to start talking a little bit faster. So, for the next one, we know these 2 things are similar. We've got to find the missing side. So we know since they're similar, they're proportional. So I'm going to set up a proportion. First, I'm going to start with the 5. What does the 5 correspond with in the other figure? That's right, the 3. I'm going to come back over here, and I'm going to now say, what does the 8 correspond with? That's right, the y. And now you simply need to cross multiply and divide. So 5 times y, 5y, 8 times 3, 24. We know that these must be equal, so 5y equals 24. And we're going to solve for y, so we're going to divide by 5, divide by 5. So 24 divided by 5 would simplify down. You say 5 goes into 24 4 times, and you have 4 remaining. So 4 and 4/5. Now, what I'd like for you to do is I'd like for you to go to the right side of your paper, and we're going to now take what we just learned and put it in a real-world situation. Something called indirect measurement. So indirect measurement is basically exactly what it sounds like. You are trying to measure something indirectly. So let's say that you wanted to know how tall a tree was, but yet you can't reach up and measure the tree. So what you could do is you could use similar figures to help you. You can always measure your height and your shadow's height, and we can use that to measure, then you measure the shadow of the tree and use that to get the height of the tree. So indirect measurement right here. I'm on the right side. So indirect measurement is using similar figures to solve for a measurement. Okay, so what we're going to do is we are going to read number 1, and we're going to use similar figures to figure this out. It says a tree stands 12 feet tall and casts a shadow that's 8 feet long. At the same time, a person casts a shadow that is 3 feet long. To the nearest tenth of a foot, how tall is the person? So that's a lot of words. So Miss Kearney says on every single one of these problems, what I want to see is I want to see you drawing a picture. A picture will help you visualize what in the world this problem is talking about. So we have a tree that's 12 feet. And this tree casts a shadow on the ground that is 8 feet. So here's the shadow on the ground. And then we've got this person who casts a shadow, so shadow on the ground, that's 3 feet. We want to know how tall is the person. So you obviously can see that the tree is forming a right angle with the ground, and you are forming a right angle with the ground. So you've got two figures that are similar. The angles are the same, the shape is the same, and the sides are proportional. So we can simply use a proportion to solve for the missing piece. So let's start with the height of the tree. What does the height of the tree correspond with about the person? That's right, the height of the person. Then we can come back to the tree and we can say, what does the shadow correspond with? That's right, the shadow of the person. And then you know how to do the rest. You're going to cross multiply and solve. 12 times 3, 36. 8 times x, 8x. And just like we've been doing, we know those cross products are equal, so 36 equals 8x. We are going to solve 36 divided by 8, and we get that that is 4 4/8, which is actually 4 1/2. And since we're talking about a person's height, they're 4 1/2 8. And that would be reasonable. Okay? So ask yourself if that is reasonable. So now what I want you to do is we've gone over a few practice. Now feel free to go back and rewatch the video if there are parts that you have questions on, or you may now begin some of the practice problems and check the key when you are ready. Make me proud, guys. Stand up, hand up, excellence in your effort, as always. Love you, mean it. XOXO. Peace out, rainbow trout.